Have you ever looked up at the night sky and wondered what that bright moving object is? Well, chances are you were seeing the International Space Station, one of humanity's most impressive engineering feats. This massive structure, weighing as much as 380 vehicles, has been orbiting the Earth for over 26 years, serving as a unique laboratory for scientific research and a symbol of international cooperation. But have you ever wondered how this football field-sized station stays up there, facing the constant dangers of space? If you're curious to learn more about the incredible engineering behind the International Space Station, be sure to hit that subscribe button and join us here at Rare Data TV. Today, we're going to dive into the secrets of the ISS, from protecting it from high-speed space debris to its ingenious method of generating breathable oxygen. The level of innovation and problem-solving that goes into keeping this station operational is truly awe-inspiring. Let's start with one of the biggest challenges the ISS faces: the threat of micrometeoroids. These tiny pieces of space junk are constantly whizzing by the station at incredibly fast speeds. And on one occasion in 2012, NASA had to urgently warn the crew that a swarm of them was headed their way. Imagine being an astronaut going about your daily routine, when suddenly you're told that your home in space could be under attack in a matter of minutes. It must have been a tense and frightening situation, but thankfully, the ISS was able to weather the storm. How did they do it? Well, the engineers behind the ISS have come up with a brilliant solution: a multi-layered bulletproof hull. Just like a bulletproof vest, the outer skin of the ISS is made up of different materials, including aluminum, woven fabrics, and more aluminum. This combination of layers helps to absorb the impact of smaller micrometeoroids, shielding the delicate interior of the station. To counter larger space threats, the ISS uses small thrusters to adjust its trajectory and avoid collisions, like a game of cosmic dodgeball. Remarkably, the station can perform these maneuvers without relying on constant rocket fuel deliveries from Earth, thanks to its ability to generate its own breathable oxygen. You see, in the vacuum of space, there's no air to breathe, so the ISS has to create its own. To do this, the station uses a clever system that employs electricity to split water into its basic components: hydrogen and oxygen. This process, known as electrolysis, produces the oxygen that the astronauts need to survive. And the best part? The hydrogen gas that's produced as a byproduct is then combined with the carbon dioxide exhaled by the astronauts to create even more water, completing the cycle. It's a truly remarkable example of closed-loop engineering, where the ISS is able to generate its own life-sustaining resources without relying on constant deliveries from Earth. And let me tell you, that's a good thing, because those cargo rocket trips from our planet to the ISS can cost a whopping $200 million each. But how does the ISS actually navigate and stay in contact with mission control back on Earth? Well, it's all thanks to some ingenious technology. First, there are the control moment gyroscopes, or CMGs, which are essentially massive flywheels that can be spun up to change the orientation of the entire station. By transferring their angular momentum to the ISS, these CMGs can gently steer the station in any direction without needing to use valuable rocket fuel. The ISS utilizes a network of high-altitude relay satellites to maintain constant communication with mission control, even when the station is on the opposite side of Earth. This allows for real-time video chats between the astronauts and their families back home, a far cry from the communication challenges of early space programs. Of course, the ultimate goal is to make the ISS as self-sufficient as possible, reducing its reliance on constant resupply missions from Earth. And the scientists and engineers working on the station are making great strides in that direction. The ISS hosts experiments studying long-term space effects, crucial as we plan crewed Mars missions. While relying on Earth for some supplies, the station's ability to generate oxygen and recycle water marks a major step towards self-sufficiency. Maintaining the ISS's breathable atmosphere and shielding it from space hazards showcases remarkable human ingenuity and international cooperation. So if you've been inspired by the wonders of the International Space Station, be sure to hit that subscribe button and join us here at Rare Data TV. we'll be bringing you more fascinating videos about the incredible technology that's shaping our future. Who knows, maybe one day you'll even get the chance to visit the ISS yourself. Thanks for watching, and we'll see you next time.